So most of the talks today are about remote sensing using night lights, and I'm going to actually take us down to earth and think a little bit about those lights themselves and how they affect any kind of retrievals that we do using night lights. So the basic question from my talk is, when we look at an image like this of Europe at night, where does this light come from? And what kind of lights does it come from? How much is from windows? How much is from cars? How much is from streetlights? And if we zoom in at a particular city and look at, say, Berlin, and see in the center of the city that we have a radiance of, in the day-night band, of 100 nanowatts per centimeter squared per steradian, what does that mean? How many lights are there? So that's a question that interests me, because one of my research interests is trying to remotely sense energy consumption for outdoor lighting, and in particular, the change in energy consumption for outdoor lighting over time. So one of the first things you can do when you're looking at this is to look at the change in light. As the last speaker said, light is not the same as electricity, but it's a start. So we did this a couple of years ago. We looked at the change in day-night band radiance over a 4-year period in every country in the world. So all the countries here, colored pink or red, are growing at a rate of more than 1% per year in the day-night band data. Several of you know that the day-night band has spectral issues. So we see, for example, China and USA look like they're steady. If we were to use a band that was similar to human vision, they would almost certainly be becoming brighter, because the day-night band is missing part of the blue information. So we know that the world is getting brighter, but it's difficult to understand because we don't know what kinds of new lights this is, right? Is this increasing how bright streetlights are, or are we having more streetlights spreading, or is it some other kind of light entirely? So before we can address that question, we have to address the simpler question of what makes up the light to begin with. So when you fly over a city at night, or when you look at the astronaut photographs from space, you get the impression, looking at them, that it's mainly streetlights that's the issue, right? So this is Calgary, Alberta, photographed by the International Space Station. And I love this photo because, or this pair of photos, because they're two of the highest resolution photos ever taken from the International Space Station. And you can see that there are some areas, I hope you can see my mouse, where the city between these 3 years in which the pictures were taken changed from orange to white. And that's because the high-pressure sodium lamps were replaced by white LEDs. So I'm going to zoom into a little region down here, and you can see this a little bit better. You can see that we can see each of the individual little streetlights there, which is really amazing. And you see that this whole neighborhood changed from orange to white. So when you look at that, you would say, wow, okay, basically all of the light is streetlights. And this is a thought that has really dominated a lot of activism around light pollution, for example, that street and area lighting is the only lighting that there is. But if we look at another region here, just north of the area that got colored with the LED, changed to LEDs, we see some very, very bright areas, and these may be saturating the camera on the ISS. So it's very difficult for our human visual system looking down at a city at night to really properly integrate all of the light and assign it to the correct categories. And so when researchers have tried to figure out how much light belongs to street light compared to other types of light, for example, they've generally come up with numbers between about 1/3 of the light being streetlights up to about half of the light being streetlights. So actually most of the light, according at least to the few studies that have been done, is coming from other sources and not from street lighting. So why is it that we need to worry about this? Well, it comes down to understanding what radiance we get in space when we look at different types of light sources. So I want to show you a few examples of this. So here's sort of the simplest case. We have a really well-designed streetlight. It's only shining downward. And so the only thing we see from space is the Lambertian reflection from the road surface. And we're going to pretend for a minute that there's no buildings around. In that case, it's relatively easy to understand. It's just like daytime. If you look at an intensity diagram, the intensity of light is highest going straight upwards and is lowest going towards the horizon. And when a satellite looks from nadir, the ground pixel is smaller, and when it looks from the side, the pixel becomes larger. And because of that, the radiance observed stays exactly the same, because these two things cancel out perfectly. So that's relatively simple. But what if we have a different kind of a light source? What if we have like a globe lamp where it's glowing in all directions? And again, this is just pretend the building is not there. And let's also pretend for the moment that the ground itself was completely black, in this case with the point source. So if we look at the intensity diagram for the point source, of course, it shines light in all directions equally. But what that means is that if you have a line of like a street lined with these little globe lights, and you look with a satellite from nadir, you'll see a smaller radiance than when you look from more at an angled view. The radiance will become larger as you go to an angled view. And this comes back a little bit. The last talk had a question about applying atmospheric corrections. Atmospheric corrections at nighttime are much harder than at daytime because there's way larger contrast in the images, and we don't know the emission function of the sources. In daytime, with the sun, it's a very simple source above the atmosphere. And if you're looking, for example, in infrared emissions, it's relatively easy because things aren't that different the way they are at nighttime in terms of the directions that they radiate and the intensities. So then there's another source of light, which is horizontal emitters. So these could be things like billboards or light shining through windows or illuminated facades. And those are now sort of more like the Lambertian reflection again, but now completely tipped on its side. And we saw really nice from 𝗖cie, these pictures where if you're looking from the wrong side, you can't see the emission at all. If you look exactly from nadir, at least for a window, you cannot see any light at all coming from the window. And then as you start to increase the nadir angle and look from the side, these sources will become brighter and brighter. So if we don't know what types of lights are making up our imagery, then our remote sensing retrievals, for example, in the last talk, trying to understand electrification or trying to understand wealth, you're going to run into problems because you may be looking at different types of lights inside of cities compared to the countryside or standalone buildings. So that's where some nonlinearities could crop in. So we wanted to address this very simple question. Okay, how much of the light comes from streetlights and how much comes from other lights? Just these two big broad categories. So we did a really nice experiment in collaboration with the city of Tucson in Arizona in the United States. Now, Tucson is interesting because a couple of years back, they renovated or they replaced all of their streetlights from high pressure sodium to LED, and they really dimmed things a lot. The other thing that they did is they introduced a dimming so that from before midnight, when they normally have the light set to 90% of maximum brightness, after midnight, they switch to only 60%. So when the day-night band passes over, the Tucson streetlights are actually quite a bit dimmer than most streetlights in the United States would be, and we should keep that in mind for what follows. So this great photograph taken by my colleague John Barentine, you can look at the building back here and see that it's staying exactly the same in the transition between before midnight and after, whereas the street is becoming quite a bit dimmer. So the other great thing is that the city agreed actually to dim the lights all the way down to 30% of their maximum, and 14,000 out of nearly 20,000 streetlights from the city were involved in the test. So that was really great. And when we look at the city from space using the day-night band on 2 different nights, we can actually see just in the image by itself that something is going on. So if you look over in the right-hand side, in the suburban areas, you can see that's dim, here's bright. There's dim, here's bright. And if you look up at other regions sort of outside the city, these surrounding areas, they stay relatively the same on the 2 nights. So how do we analyze this data, right? We don't just look at the picture. If you imagine that a city had only streetlights and had no other lighting at all, then you would have perfect proportionality between the light emission of the streetlights and the brightness of the city seen from space. So if the city doubled the brightness of the streetlights, then it would also double how bright the city was. This proportionality breaks down when you add other types of lights, but the slope and the linearity stay exactly the same. So what happens is basically this whole curve just slides up, and you add in these other lights that have nothing to do with what the city is doing with its street lights. So now that you understand this graph, I can go to the result and show you that. And you see that the slope is much flatter than what I showed in the example diagram. And that's because the total emission from the city of Tucson streetlights is really quite small. So on a normal night when they're dimmed to 60%, the streetlights only make up about 13% of the total light emission from Tucson. And if the city was not to dim their lights, it would still only be about 18%. That's this high point over here. If you look inside the paper, you'll see that the situation is a little different in the city center and the outskirts. You know, we expect that in the city center, there's a lot more advertising lighting, and the outskirts, streetlights become more important. So I'll let you go and see the paper to see that. But I do want to show you some results from some German villages where we did a similar experiment. Now, in this case, we're not using LEDs. These are high-pressure sodium lights that are being dimmed. So we can't use streetlight power anymore, but we have the relative luminance. So it's the same idea. So this is a bright night, and then down here are the dimmed lights. Now, in the dimmed condition, we see that these villages are only, again, about 30% to 40% of the light is coming from the street lighting. Now, if they were not to dim, of course, the street lighting would make a far, far higher proportion of the total light emission from these villages. And this brings me to a point I wanted to make regarding the last talk, that, you know, in the ideal case, many places should not be illuminated at nighttime, right? Villages may not need to be illuminated or not illuminated brightly. And so it would be dangerous to expect that you must be illuminated to be considered developed. And what we actually see is that many regions in Germany, for example, in small villages, are unlit at nighttime in the daylight band, because they are using an environmentally conscientious lighting strategy. So that's the end of the Tucson results. I just want to make a teaser basically for a new project we have called 𝗖licheห์ So this is a German name, so I need to explain it. And before I can explain the name, I have to explain where I come from. So I work at a Helmholtz Institute. The Helmholtz Association is the largest German research group in Germany, basically. And it is the Helmholtz centers are the ones that sort of do the really big science in Germany. So, for example, the German Space Agency, DLR, is a Helmholtz center. And the Alfred Wegener Institute, who operates Germany's research vessels like the Polarstern, they are also Helmholtz. They're a Helmholtz center. So Bühne stands for the Citizen Helmholtz Network for Research in, and then in our case, nighttime lights. So this is part of an experiment by Helmholtz to try and see how could citizen science plug into this sort of large research organization that Helmholtz runs. It's a play on words. Bühne means stage. So we can say that all the world's a stage. And in this project, what we're going to do is count the stage lights. So the idea is we want to have citizen scientists go along streets, and we assign them from one street corner to the next. They'll go there and then click the plus button to start doing a transect. And then they come to a light and they categorize it. You know, is this a street light? Is it a parking lot light? Is it a floodlight? Is it some kind of a sign, video screen? And then after they've done that, they can give us a little bit more information. So for example, if it's a street light, is this one of these globe style lights like these ones in the picture here, shining in all directions? Or does it have some kind of a shield so that what the satellite is going to see is only reflected light? And in the case of signs, of course, we need to have some idea about how large they are. So we do that using human proportions. And all of this is being co-designed, co-developed together with a team of citizen scientists. So we are person power limited on the project. And if you are interested in this ground truth data that we're going to be developing, please get in contact with me. I'd be happy to have some other people to help me analyze it. So we plan to compare to the day-night band and also 𝗖଼ecieห์ and also potentially with some aerial imagery we'll be taking over the city of Cologne later this year. So looking forward to your thoughts regarding the presentation and lights on the ground.